In this video, we'll look at a few more tricks that Sysop-64 enables. We'll leverage the FPGA's shadow memory to inspect a running program. Then we'll use DMA to patch it on the fly. We'll also make use of the Commodore 64's I/O space for a new register to enable communication between a Linux program and the C64. We'll use the frame buffer overlay to add a heads-up display. We'll tie it all together to enable use of modern wireless game controllers with the Commodore 64. We'll also look at some customizations for a few games in particular. Alright then, let's dive in. Anytime the Commodore 64 CPU does a write to memory, a copy gets written into a block of shadow memory inside the FPGA. That memory can be read from the Linux side without impacting the 64 at all. For example, here in the shell, we can use the ipeek command to read the contents of the screen. We'll put the shadow memory to good use in just a minute. But first, let's talk about joystick support on the Sysop-64's Linux OS. Linux has support for a wide range of game controllers, including USB joysticks as well as wireless gamepads. Here we'll be using this 8-bit DOE wireless adapter. I asked ChatGPT to write up some joystick handling code, including all the necessary code to monitor for joysticks being plugged in and removed. I then modified it to update our new register in I/O space based on the user's input. For this demo, we're going to start a game and then inspect memory to find the code that reads the joystick port. Then we're going to use DMA to patch the code on the fly and redirect the read to a new location in I/O space. Make sure the FPGA's I/O memory has been enabled, either from code or with CMD7 from the Linux shell. Note that only one thing plugged into the cartridge port should be using the I/O range of memory, so make sure you know what's being used by anything plugged into the pass-through port. If in doubt, don't plug anything into it while doing this. Let's try it out on one of my favorite test programs, Giana Sisters. That's pretty cool, right? Now, of course, how about mapping a button to jump instead of using up? Let's make a quick change to enable that in the code. That's much better. Let's switch to my PAL machine and try a few more. Next up is Commando. I sure wish I had a button for that grenade instead of having to hit the spacebar. We can use that same technique of locating code and patching it in this case too. And there you go, much easier. Let's try another example. How about Drop Zone? What this game really needs is auto-fire. Let's devote one of the buttons to auto-fire and also provide a way to increase or decrease the rate of fire. I've got the shoulder buttons configured to increase or decrease the auto fire speed. I sure wish I had some way to indicate visually what the speed dial was set to. Here's where Sysop-64 shines. Remember, we've got that frame buffer we can use to overlay additional graphics on top of the Commodore 64's display. Of course, that's only visible on the HDMI output of the Sysop-64. Let's add a sort of heads-up display to show our auto fire rate. Okay, now we've got a simple bar graph to show our auto fire setting visually. This game originally required the keyboard for the cloak as well as the strata bombs. Let's assign buttons for those too. You're probably thinking there must be some way to generalize the pattern here of detecting the running game and applying the right patches. For sure, that's a great next step to take from this example. With all these improvements, I finally might stand a chance in this game. For those of you running the early alpha builds of Sysop-64, to try this out, you'll need the new kernel image that has joystick support enabled, as well as the FPGA core that enables the shadow memory. In this video, we've seen a simple example of patching running C64 code on the fly from a program running on the Linux side of Sysop-64. This simple technique unlocks all kinds of ways to have fun with your Commodore 64. Please share your ideas on what you'd like to see or try for yourself. Don't forget, please like this video and subscribe to show your support for this project. Thanks for watching. See you next time.